Good evening, ladies and gentlemen. Tonight we are starting Unit 5. Unit 5 is going to be all about adding fractions. But before we actually can start adding fractions, there's some other skills that we need to learn. So our goal tonight is that tonight I will simplify fractions using something called the GCF. And we will learn what that is together. Okay, our first vocab word is fraction. Fraction is just part of a whole. So in units 3 and 4, we did everything about decimals. Decimals are also parts of wholes. So a fraction has two parts. The top part is called the numerator, and it's how many parts you have. And the bottom part is called the denominator, and it's how many parts the whole was cut into. Sometimes we'll also see verbs like split, divided, could be any of those, but how many pieces it was cut or divided into. So for example, in this fraction, 2/3, this means that there was maybe a pie and it was cut into 3 pieces, but the numerator 2 tells us we only have 2 of them. Okay, so what we're going to be doing tonight is learning how to put fractions in simplest form. You know fractions in simplest form when the numerator, which I'm going to use an N for, and denominator, D, have only 1 as a common factor. So it means their only common factor is 1. Okay, and we'll see what that looks like together. Okay, our next word is equivalent. Equivalent is just another word for equal. We're going to see this throughout the next unit. You're going to see it a lot when they talk about fractions. So you learned this when you were probably in 3rd grade. So if I made a pie and I cut it into 2 pieces, my denominator would be 2, but I only have this 1 piece, my numerator is 1. But if I took that same pie and this time instead I cut it into 4 pieces, which is my denominator, and this time I have 2 of the pieces, although my fractions look very different, this is what I would call equivalent fractions. They're worth the same amount, okay? Okay, what we're really talking about tonight, though, is these thing called factors. So we've talked about the word factors already when we've talked about numbers, and it's going to be the same thing, numbers being multiplied. So numbers that can be multiplied to get a product. So for example, 4 and 5 are the factors for 20. 4 times 5 is 20. For 12, I could say 3 times 4 are the factors of 12. So these are my factors, and this is my product. Sometimes I always think of also factors fit in perfectly to the number. So 4 fits into 20 perfectly. It fits in 5 times. And 5 fits into 20 perfectly. But if I took a number like 3 does not fit into 20 perfectly. It fits in 6 times, because 3 times 6 is 18, but then there would be some left. And it won't fit in 7 times, because 3 times 7 is 21. So 3 does not fit in perfectly, and the reason that is because 3 is not a factor of 20. Okay. What common factors are is they're just factors that 2 or more numbers have in common. So common just means you share it. So maybe you and your friends have a personality trait in common. You're both funny, or maybe you have shoes in common. So the common factors just mean factors that 2 or more numbers have in common. Okay, greatest common factor is the greatest factor 2 numbers share, which is where that GCF comes from. So it's greatest common factor. So when we said our goal today is to simplify, using this GCF, or greatest common factor. Okay, before we can get started, we have just a kind of a reminder from last year. So this is our notes. Last year you probably did something called rainbow factoring. We're going to do rainbow factoring, but we're going to kind of ditch the rainbows. They get really messy. So I'm calling it rainbows without the rainbows. But I'm going to do the same idea. So for 9, I'm going to ask myself, what can I multiply together to get 9? And I always want to start with 1. So 1 times 9 gives me 9. 2 times doesn't work. So let's do 3. 3 times 3 gives me 9. And I'm going to stop because I have a repeat. Okay. And then let's try 12. I always start with 1. So 1 times 12, 2 times 6, 3 times 4. And I'm going to stop because the next number I would try would be 4, and I already have it. So if you notice, I always started with 1 and I kind of counted up, and then I stopped when I would get a repeat. Okay, so let's look at these. This one, they have 1 in common. They both have 3 in common, and that's it. So the greatest common factor is the 3. Okay, we're going to actually skip this one because we have a lot of them. Let's go on to the next one, which is 5/8. Okay, so I'm going to always start with 1. 1 times 5, 2 doesn't work, 3 doesn't work, 4 doesn't work, and then 5, I'm going to stop. Okay, 1 times 8, 2 times 4, 3 doesn't work, and then 4, I have a repeat, so I'll stop. So notice this time my GCF is 1. Okay, let's try another one. Ready? Okay, 24. So we always start with 1. 1 times 24, 2 times 12. Oh, this is a tricky one. 3 times 8, 4 times 6. 5 doesn't work, and then 6 would be a repeat. So let's try 36. 1 times 36. Oh, this is a really hard one. 2 times 18. Not sure how many of you got that one. 3 times 12. 4. Does 4 work? And if you're ever like, I'm not 100% sure, you can just pause and kind of think, but it does, because 4 times 9 is 36. 5 doesn't work, and 6 times 6. And then I'll stop because I have a repeat. Wow, look at how many factors these ones had. They both have a 1, they both have a 2, they both have a 3 and a 4, they both have a 6, they both have a 12. So this time the GCF is 12. Quite a lot. Okay, I think we're going to skip this one and go down to our last one together. Okay, so we already did, we didn't do 12 actually. So 1 times 12, 2 times 6, 3 times 4, and then I have a repeat. 1 times 20, 2 times 10, 3 doesn't work. 4 times 5, and then I have a repeat. So what do they have? They have 1, 2, and 4 in common, but my GCF is 4. Okay, so that was hopefully a quick reminder. Okay, our steps today is, what you're going to do is you're going to find the GCF of the numerator and denominator. We're going to be writing numerator and a denominator a lot this unit, so I'm going to use these just capital letters to remind us. So I'm going to find the GCF of the numerator and denominator, and then I'm going to divide both the numerator and the denominator by the GCF. And if there happens to be a whole number, I'm going to leave it alone. Okay, so what does this actually look like? So here is my first fraction, 18/27. Now sometimes fractions are written like this. I prefer when fractions are written like this, but they both mean the exact same thing. Okay, so what did my first step say? I'm going to find the GCF of, I'm going to find the GCF of the numerator and denominator. So let's come down here. For 18, I have 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and then 6 is a repeat. Okay, for 27, I have 1 times 27, 2 doesn't work because it's odd, 3 times 9, 4 doesn't work, 5 won't work, 6 won't work, 7 won't work, 8 won't work, and 9 already is there. So, what do these have? They have these in common, but my GCF is a 9. So I found the GCF of them, and then it says I'm going to divide both the numerator and the denominator by the GCF. So I get 18 divided by 9 is 2. 27 divided by 9 is 3. So what I actually did is I created an equivalent fraction to 18/27s. These are actually worth the exact same. This is just the simpler way to write it. So they're both worth the same. This one just shows me it in smaller terms. Now, how do I know that? Well, if I really looked at what 18/27 looks like, it's going to take a moment, but let's look at what that looks like. 18/27, okay, means that something was cut into, okay, something was cut into 27 pieces, which is quite a lot of pieces. So let's see how we could go about doing that. If it was cut into 27 pieces, I might start by cutting it into maybe ninths, and then maybe I'll cut my ninths in like this. Okay, let's see if that's really 27 pieces. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 times another 9 and another, or plus another 9. That's 27 pieces. And this time I had 18 of them. So I'm just going to do an X to kind of make it not so messy. So that's 3, 9, 12, 15, and 18. So that's how many I had. Well, what would this look like if it was 2/3? So the reason they're equivalent is this time I cut it into lots of little pieces, but I'm going to kind of get a different color to show you how it would be exactly the same. Okay, if I had taken the same piece and instead of cutting it into 27 pieces, I only cut it into 3 pieces. So now notice my 3 big pieces. How many of the big pieces do I have? 2. 1, 2. So it's the exact same amount. This is just a simpler way to write it. Okay, let's see one more. Okay, this one looks a little different because now there's a whole number. Again, I don't like when they're written this way, so what this really says is 1 and 9/12. So I'm going to do exactly the same thing. I'm going to find the GCF of the numerator and the denominator. So let's come down here and find it. 1 times 9, 2 doesn't work, 3 times 3. 1 times 12, 2 times 6, 3 times 4. So it looks like my GCF is 3. So I'm going to come up here and divide by 3. And this time I get 1, because I don't do anything to my whole number, and 3/4. And that is an equivalent fraction, but it's the simpler fraction. Okay, so let's try a couple together. Okay, so here's our first one, 15/20. Okay, again, if you are like me and you prefer it this way, I don't know why, but I prefer it to look like that. So we need to find the GCF of the numerator and denominator. So I might just come over here and do it. 15 is 1 times 15, 2 times nothing, 3 times 5, 4 times nothing, and then 5's a repeat. 20 is 1 times 20, 2 times 10, 3 doesn't work, and 4 times 5. So what's our GCF? 5. So let's come over here and divide both by 5, and we get an equivalent fraction of 15/20 is 3/4. Okay, let's try another one. So this is telling me 1 and 14/20. Okay, so we need to find our GCF of our numerator and our denominator. So 14 is 1 times 14, 2 times 7, 3 doesn't work, 4 doesn't work, 5 and 6 don't work, and 7 would be a repeat. So 1 times 20, and we already did it up here, so sometimes we could just copy the ones we've already had. So this time, what's our GCF? Ooh, our GCF looks to be like that. This time our GCF is 2. Okay, so when we do this, remember we have to leave our whole number 1 alone, and we get 14 divided by 2 is 7, 20 divided by 2 is 10. So an equivalent fraction for 1 and 14/20 is 1 and 7/10, but this is the easier or simpler way to write it. Okay, sometimes you'll come across really big ones like this, which seem a little like, oh, scary, but you're just gonna jump in and do the same steps. So for 21, we know it's 1 times 21. 2 won't work because it's odd. 3 times 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. So that one only has 4 factors. Okay, for 56, we know it's going to be 1 times 56. I know 2 works, and the reason I know 2 works is because this is an even number. So if I wasn't sure, I could say, well, 2 times what is this? You could even do like a little division if you needed to do some side division. Like 2 can go into 56 how many times if you needed to figure it out. So it's actually 28. 3, again, if you're like, ooh, I don't know, you might have to do some division to figure out if 3 works. I'm going to give you a hint, it doesn't work. Okay, so I do know 4 actually does work, and this one is 14. I'm kind of helping you with that one. 5 does not work. 6, most of us know our multiplication tables really well. 6 will not work. 7 does work. 7 times 8. So this one was a tricky one, and my GCF is actually 7. That was my GCF. So I'm going to divide them both by 7, and I get 3/8 is an equivalent fraction. Okay, so ladies and gentlemen, you have some homework. And then, as always, rate yourself and have a wonderful night. Good night.